Hello everyone, welcome to the video. Today we're going to talk about the OEE calculation in the manufacturing. OEE stands for Overall Equipment Effectiveness, and it's an indicator used to evaluate the performance of a certain production line in the manufacturing or any process that produce parts, making parts in the manufacturing world. The calculation of the OEE, it's the availability multiplied by the performance and multiplied by the quality. The availability is the calculation used to capture the downtime it's happening in the equipment or in the production line. Anything that we haven't planned and causing the line going down. So availability by calculations like planned running time. If you schedule to run the line for 2 hours or 8 hours, minus the unplanned downtime if we have any maintenance issue or anything that causing the line goes down, divided by the planned running time. Performance, it's the indicator used to capture the performance of the manpower of the operators. Um, so it's going to be the actual production rate, how many parts we produce by the end of the shift or by the end of the planned running time, divided by maximum production rate, how many parts that the operation is supposed to build. Quality is a number of finished goods that we build divided by actual production rate. And the quality is the indicator to capture how many defected parts that the system built. We have an exercise that we are going to use to make a quick calculation of the OEE. And let's go to FlexSim. Okay, so we can use this simulation of a certain machine, one operator, and this machine run 10 seconds of the cycle time. Parts comes from this side, from the left we have like the WIP, the work in the process parts, and then it goes through the machine, could be any kind of operation, and the operator is doing the unloading. The finished goods goes here. If we have any scrap parts, it's going to go in this location here. So we can go ahead and run the simulation. We schedule to run this for 2 hours, starting let's say 8 a.m. to 10 a.m. So that's 2 hours planned running time. So we start the simulation. The way I made it, like we're gonna have a downtime. We call it unplanned downtime, which is waiting for material. We have like around 2 minutes of unplanned downtime waiting to getting WIP parts. That's considered a downtime, and that's going to affect the availability. And we can keep running. Let's slow it down a little bit. So the operator is just unloading the parts from the machine, and it could be this is like a bin for finished goods or anything like that. So we have more downtime. It's around another minute waiting for materials. So we have another 2 minutes of unplanned downtime. So we have 4 total. Okay, another unplanned downtime. We're waiting for more parts. Okay, so we can go ahead and speed up everything. It looks like for every 10 parts coming in the WIP, we have like 2 minutes of unplanned downtime. Okay, I'm speeding up the simulation so we can get a quick results here. All right, it's almost done. So that's 9:30. The simulation stopped by 10 o'clock. So we can collect the data here. So we have 326 parts that we build in the production. That's a total. Here we build available, so production rate 326. That's a total. How many scrap we have? We have 10 scrapped parts. So So by the input, we have scrap of 10 parts. That's going to help us to calculate the quality. Now we need to downtime. So we know that for every 10 parts, we have around 2 minutes downtime. So we can do a quick calculation here. We build, 326 divided by 10 multiplied by 2. We have around 65 minutes of unplanned downtime, 0.2. That's the downtime that we had comes from waiting for material, and this is unplanned. We have to do something about that in order to improve our production line. So I think we have enough to calculate the OEE right now. Availability is going to be, we run for 2 hours, that's 120 minutes, and we lost 65 minutes. So by availability, we have like 45%. That's pretty low, actually. Okay, now we can calculate the performance, the actual production rate. The total parts we built in the simulation was 326 parts. That's a total. And now we have the machine cycle time. So that's a given. It's a 10 seconds per part. In order to match the units, we have to convert 16 seconds to minutes. That would becomes 16.16 minute per part. That's the machine cycle time. So now we need to calculate the maximum production rate. The maximum production rate is depending on how much time we had available to run the machine. We had 120 minutes minus 65.2. So 54.8 minutes. That's a total time was available to run. And to calculate the maximum production rate, we have to divide it by this machine cycle time. So it was a 16.16 minutes. 0.16. Okay, so we have around 342.5. 342.5. So now we can calculate the performance here. We have 300. We have total parts we made 326. I'm sorry. Divided by the maximum production rate, which is 342.5. There's no half part 0.5, but that's gonna really help. We can actually leave it like this, leave it like this. All right, so we have 326, 342. So we have like 95.95. So that's the performance. Last thing is we calculate the quality. We have 10 defective parts we built of 326 total parts we build. So we have to go by 326 minus 10 divided by 326. Let's see how much we're gonna have. 316 divided by 326. So the scrap of the quality is 0.969. Then we can fix that real quick. It's going to be 97%. The OEE calculation is going to be multiplying the availability performance by the quality. So we can have 0.45 multiplied by 0.95 multiplied by 0.97. So the OEE becomes 41%. So this kind of simulated production, we have a lack of delivering materials on time, and that consider a waste, and also it's a downtime that causing the production running slow. This is a good example that we use the OEE calculation to evaluate the overall performance of a certain production line. So that way here from this example, we can see that we have a good performance, 95%. We have a good quality. However, the availability was pretty low because we have a lot of downtime comes from waiting for material. So from here is we can tell like, okay, maybe is we have too much traveling from whoever delivering the material to the production line. So maybe they don't have enough time to go this task executor. Could be a high load, could be a Tiger system. So something we can fix to deliver that material on time. So the production is not going to wait, production line is not going to wait for materials anymore. And that way we can actually build more parts. That's all I have for this video. Thank you for watching, and I'll talk to you later.